Hello. Okay, here we go. All right, just gonna stop this for a moment. Don't really need notifications that we're streaming every time I go live. Okay, just gonna wait for some people to pop in if that happens. Just a moment. Sorry for that. Apologies, my heater just turned on. How do we pop out chat again? Apologies again, I'm really terrible at this entire thing. I think you think I would look into what I'm doing. I haven't. Oh, by the way, if you are here, just be glad to hear from you. Right, so apologies. What I'm currently doing right now is trying to see if I'm live on YouTube. If I'm not, that would kind of suck. I am. Alright, so the VOD is going to be saved in the end of this. At least, perhaps I'm doing use out of this. I hate YouTube. The UI for this is just terrible. I have no idea what I'm doing at any point. Like, you need a degree. Look, I'm an idiot. They should make this idiot proof. Right, so I guess what we're doing today, if we can get some people in here, is going to be talking about what we've learned. As well as what we're going to be doing over the next little bit. However, currently, doesn't seem like anyone's joining in, which is perfectly reasonable. At least we have the VOD afterwards, so people can actually see what's going on. We had a pretty good showing first day, so I expect a bit of a drop off, but, is what she is. We are live on we are certainly live on YouTube. That is good news. Okay, we've hit up the 4. Still don't have any people in chat, which is a shame, but How do you pop this up? I did it last time. My god, am I ever an idiot. Congratulations, everybody who came in first. Hello, Silver Sorbet. Love that name. Fantastic name. I'm very glad. You're the first guy here to talk. Anyway, welcome to the stream. You get to see how incompetent I am. Congratulations. Here we are. There, now we have this on screen, so we can see it while I, dick around. There we go. Look, there's probably some way to get chat to appear in some nice and very well shown way, but I think I've stated I am an idiot. Ah, 5 people. Looks like people are popping in. Right, so today we are going to be reading through the next 2 chapters, Common Programming Concepts and Understanding Ownership, which I'm going to run through Common Programming Concepts fairly quickly. I think this is something we've all learned before if we've done anything before, but still going to go over it a bit. Mutability specifically, I believe there's quite a bit of a difference here, but hey. First, though, I'd like to talk about what we've learned in the past 2 lessons, I guess. Not too much, I guess, just how to build out a Rust program, how to install it, how to build it, what cargo is, a little bit about mutability, and pattern matching. I love this, I really do. If anyone else wants to speak up on what they've learned or anything outside of this 2 chapter reading we've done, love to hear it. Love to hear what people have been doing recently with this. Personally, I've been looking into its uses outside. Please feel free to chat if you want to talk about it, but it's actually been getting pretty good roll-up in less so in the web development side, which is strangely what Lemony's chosen to do. I don't fully understand why. I'd love to learn that eventually, however. It's going to be a bit of a goal to myself to figure out why Lemmy chose Rust over any other language. Go would make a lot more sense, I'd argue, but hey, they're doing this. It's going to be really good for the servers, I guess. Low data usage, low CPU usage. Always good to see, but you know. Hey, RJ Gonza 87. I'm just going to call you Gonza unless you have a better name to talk to for me to call you. Love to see you here, Gonza. Hello. Glad to hear. So, Gonza and Silver Sorbet. Really curious what you've been learning about Rust. Is this your first time coming in? First time really learning about Rust in any way? Have you been looking into the documentation, or what really is your level of knowledge here? I think that's what a lot of people do. I keep trying, but I keep failing, really. Keep getting set up, keep going through the first little bit, but you know, kind of hard to dedicate yourself to something that's not currently useful for work. Very excited for this opportunity to try and really dedicate myself to learning this, something weekly place to actually learn this instead of just trying as I will. But I'm glad. Got a newbie here too. Third attempt? Oh, wow. It's always like that, isn't it? I know Python and did some C++, but that's about it. Oh, wow. I'm glad to have a newer programmer here then. If you've just done... Oh, you know Python. Never mind. Newer to lower level languages. Oh, wow. Gonza has a lot more experience than I do. That is very good. You have an internal tool at work. I'd love to know more about that. Ah, glad to have somebody who's a bit newer and somebody who's a little bit more experienced than me. That is very good to see. So I am so sorry that you did some C++. That is a horrible language to work in. I really hope that wasn't for work, Sorbet. It's for managing IP addresses on a server. Okay. Good thing to use Rust for, I guess. Something that you're not going to touch too much. Something that you want to be quite secure, memory secure. Why, good. Anyway, I'm very glad to have you guys here. I think... What exactly did I say we were going to go through? I will always forget things. To clarify, I am an idiot. Which is always good, you know? Yeah, I guess that's really all I was stating I was going to do. Right, so just to go over what we learned originally, it wasn't very much. We just did a small hello world, hello cargo. Ethanator! Hey, welcome back. Love to see you here. We got two new people. Awesome to see. We're just going over what we had done previously. Unless you wanted to specifically state what you've learned since last time. What you've been thinking about, what you've been learning in the Rust community. First thing, I was just going through how we learned what a hello world was, cargo, the tool to install stuff, a lot like npm, if any of you have ever worked in the web development world. Just to install, what is it called? Dependencies. Keep track of them in a really nice command line based way. I think it's a good system. Anyway. Once more, I think that's about all for now. We've not learned too much so far, so it's a great day to jump in. Of course, you can go and watch the VOD previously, and I'm going to edit it down a little bit more in case you get a bit, things are a bit lost. Sorry, in case you get a bit lost. And I would like to preface this with the fact that I'm going to be fairly awkward in this. I've never done this before, don't know what I'm doing, and am a failure generally in life, which, is fine with me, honestly. I've got no issue with that. But I'm going to talk incorrectly, I'm going to ramble on, and I'm going to say some fairly strange things. Apologies for that, but you know, is what it is. Sorry to hear, Keith. Oh, it does help with testing. Formatting too? So it's a lot like Go. I think every language should have something like that, Gonza. Every single language should have something just built-in testing, built-in build, built-in help, built-in formatting, everything. Fantastic. Don't see why more don't go with that section, that solution. I guess it's kind of hard to build, though, I understand. Also, it does break Unix philosophy a bit to have it all wrapped into one thing, but who cares? Everything breaks Unix philosophy, even Unix. Right? But yeah, no worries, Keith. I haven't really touched it. I've been reading articles on my phone. The Linux kernel brought in some Rust. Now I can pretend to be learning this in order to contribute to the Linux kernel before inevitably figuring out that I'm not that intelligent. But yeah. Right, again, I think it's time we start reading this, unless anyone has anything else to bring up or talk about. We're going to be talking about common programming concepts, and I'm going to be running through this quite quickly. This chapter covers concepts that appear in almost every... Cosmic! Yes, Cosmic is written in Rust. Oh, I'd love to contribute to that. Looks amazing. I'm on KDE Plasma, so it's going to be an entire thing to change over, but hey. This chapter covers concepts that appear in almost every programming language and how they work in Rust. Many programming languages have much in common at their core. None of the concepts presented in this chapter are unique to Rust, but we'll discuss some of the context of them in the context of Rust and explain the conventions around using these concepts. Specifically, you'll learn about variables, basic types, functions, comments, and control flows. Flow. This foundation will be in every Rust program, and learning them early will give you a strong core from the start. Keywords. Yep. We can understand what a keyword is. It's just a word which you cannot use for anything else that has an effect. Right, variables immutability, as mentioned, variables are immutable, meaning cannot be changed by default. I really love this. That is fantastic. Right, yeah, it's a nudge that gives you safety and concurrency. However, you can still make it mutable. Again, I'm just going to be skimming through this section. It's something every other language has. I'll be looking for things that are useful. When a variable is mutable, once a value is bound to a name, you can't change that value. Well, yes. To illustrate this, generate a new project called variables in your okay, fine. Using cargo new. Oh, that is not good, Silver Sorbet. Please don't do that. Hello, can you do the size missing? Okay, fine. Yeah, I'm definitely not worth the cost of streaming data to your phone. Alright. And of course this is still broken, so let's make a directory called day2. cd into it. And let's use cargo to init. I guess it's cargo new, of course. Why can't it be init? We are going to call it variables. Fantastic. Simple hello world right now, but we are going to delete that. We're going to let x. Are we going? This is literally just going to show that you can't change the variable. It will fail with a very nicely written error. I'm not going to do this. Who really cares? We can understand. Once you've put x, you cannot change it to 6. It will tell you that we cannot use it, that we cannot change it unless we put mute on it. We can understand that. That's really good. I like that. This example shows that the compiler finds errors. Errors can be frustrating. Don't give up. They do not mean that you're not a good programmer. I don't think that needs to be typed out. Good programmers get the most errors. We fail fast. Experienced rustaceans still get compile errors. Just get them quicker. We received the error message cannot. Yep, we understand. It's important that we get compile time errors when we attempt to change a value that's designated as immutable because this very situation can lead to bugs. Yes, of course. Yep. If our code, yep. Sorry, I'm just reading this. This is useless right now. Apologies. This is just re-explaining the same thing 30 times. I guess that's kind of useful. But mutability can be quite useful. Use the mute keyword to allow us to change it. That's good. Now if we run it, it'll work. Let's start a quiz, see how badly I failed. We have to reread the entire thing. Which statement best describes what it means if a variable x is immutable? Can't be changed. X cannot be changed after being assigned a value. Correct. Let's just read the others. X is stored in the immutable region of memory. That's not a thing. After being defined, X, well, I don't know if that's a thing, but I don't believe it to be a thing. After being defined, X can be changed at most once, and you cannot create a reference to X. X can't be assigned a value. What is the keyword? It's mute. Or mut, I guess. Determine whether the program will pass the compiler. If it passes, write the expected output as if it were executed. That x equals what? Right, that does not compile because it's not mutable. They're really bashing our head over with this. Like, I can understand that, honestly. Like, if somebody doesn't understand this concept, they're going to have a very bad time. So I can understand just bashing us over the head with it. Right, to confirm, you can't change any variables unless you put mute in front of it. Constants. Unlike immutable variables, constants are values that are bound to a name and are not allowed to change. But there are a few differences between constants and variables. First, you aren't allowed to use mute with constants. Constants, yep, they're constant. Can't change it. Constants aren't always, they're just always immutable. declare using the const keyword instead of let, and the type of the value must be annotated. We'll cover types and type annotations in the next section. Okay, so yeah, I didn't know that. Consts need to be annotated with a type, like this. Okay, that's fine. They can be declared in any scope, including global, which makes them useful for values that are in many of the parts. Yep. You'll find out where constants are needed in certain places. Try not to use them though, they're not useful. Well, they're useful, but they're very bad to run. They can make your code unreadable. Don't use them if you don't need to. Constant's name is 3 hours and seconds. I see they use caps with underscores. Reasonable, that's what you should do with consts. Right, yep, that's just now. Const is value are valid for the entire time a program runs within the scope in which they were declared. This property makes constants useful for values in your application domain that multiple parts of the program might need to know about, such as the maximum number of points any player in a game is allowed to earn, or the speed of light. Naming hard-coded values used throughout your program as constants is useful in conveying the meaning of that value for future maintainers of the code. It also helps to have only one place in your code that you would need to change if the hard-coded values needed to be So have a const file. Good. Which the following statements is correct about the difference between using let and const to declare variable. No, it won't. Sorry, the compiler will not give out an error if it's using upper snake case. There are just different symbol syntaxes for declaring variables with the same semantics. Const can be used in the global scope. Let can only be used in a function. Const can only be assigned to a literal, not an expression involving computation. This last one I can understand why a person would think it, but we had an example with that 60 times 60 times 3. I believe let can be used in global scope. Can it not be? Well, first off, can we put a const here? Oh, yeah. Yep, so that's fine. What about let? Oh, okay. How does const distinguish from not using mute? Is it mostly to let maintainers know it should never be mute? I don't think so. Like, look here. Huh. That is a good question, Keith. I do agree. It would be it's a bit strange here. But I am. In this situation, I am actually allowed to put const in a global scope. But I'm not allowed to use let. Is const supposed to be specifically for global scope? Then why allow it here? I don't fully understand that. Yeah, that is a good question. I suppose... Oh, perhaps shadowing. Can you shadow with const? Yes, you can shadow with const. Shadow is when you use the same name, change the variable. Does this compile? If this compiles, that's a shame. Thank you, Silver Sorbet. Let's check this out. We have a Stack Overflow answer. I do appreciate that. And thank you, Keith, for bringing it up. Oh yeah, shadowing is just when you take a variable, like here we have const here, and then we redefine it later on as the same name. So we are creating a new variable called there. So we have here and there. However, if we, apologies, I'm not speaking correctly in this situation. It's just when we create a new variable with the same name, so we can't use the old variable and instead use the new variable with a changed name, with a changed value. This is commonly used when we change it from like a U32 to a U16 or a U8, changing it from one type into another type, like into a Argonza. Oh, I didn't read that. I think const is compile time and let happens at runtime. Wow, yeah, that's true. That's great. I guess I'll just read this out loud. Constant Rust is short for constant, is related to compile time evaluation. It shows up when declaring const, when declaring compile time evaluation functions. Oh, yeah, yeah. These kinds of values can be used as generic parameters. For now, this is limited to array size, but there is talk, plans, and hope to extend it further in the future. By contrast, a let binding is about a runtime computed value. Note that despite mute being used, because the concept of mutability is well known, Rust actually lies here. Redirection T and direction of mute T are about aliasing, not mutability. A shared reference? It's a unique reference. Okay. Okay, most notably, some types feature interior mutability and can be mutated via @t, shared references, cell, ref cell, mutex, etc. Huh, okay. All right, yeah. Again, thank you for that, Silver. And thank you, Gonza, for, well, answering the question before I saw it. I really do appreciate that. Anyway, I guess let's continue. They are not just semantic differences. Can be used in the global scope, and let can be used in a function. Okay? I guess for now, all they want us to know is that const can be used in global scope, and let can only be used in a function. Determine whether the program will pass the compiler. If it passes, write the expected output as if it were executed. Const 2, 32 equals 2. Print 2. I assume it would compile and would print out 2. Good stuff. Shadowing. Ah, here we are. Let's get a much better explanation than the really piss poor explanation I gave you. Sorry about that. As you saw in the guessing game in Chapter 2, you can declare a new variable with the same name as a previous variable. The stations say that the first variable is shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable. In effect, the second variable overshadows the first, taking any use of the variable to itself until either it itself is shadowed or the scope ends. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follows. Let x equals 5, let x equals x plus 1 would be 6. We have a new function here. I believe, well, this is a new scope no matter what. Let x equals x times 2, so that would be 12. Okay. To confirm, just explain this a little bit further. We have x, which equals 6 at this point. We enter here, where we create a new variable called x. So any reference of x will go to this x instead of this and this x inside the main scope. But once it exits this, you'll go back to 6. This program first binds x to a value of 5, then it creates a new variable x. Oh, that's shadowed twice. Apologies for that. X by repeating let x equals taking the original variable and adding 1 to the value of x is then 6. Then within an inner scope created with the curly brackets, third let statement also shadows x and creates a new variable multiplying the previous variable value by 2 to give x a value of 12. When that scope is over, the inner shadowing ends and x returns to being 6. When we run the program, it will output the following. I don't think we need to run this, but we can understand. Is anyone confused by this? just to make sure. I could fully understand if a person wants. This is a fairly weird concept, but I'm really interested. Hopefully this isn't used too much. This is a bit obscure. I can understand what it does. Just putting brackets to create a new scope. I just kind of hope that this isn't used very often. I assume people just use they're mostly talking about for. Glad to hear, Keith. Shouting is different than marking a variable as mute because we'll get a compile time error if we accidentally try to reassign this variable without using the let keyword. By using let, we can perform a few transformations on a value, but have the variable be immutable after those transformations have been complete. It's a way to change mutable variables. Really, it can be done. Yeah, can you? Can you? Apologies. I think I may have lied there, and I kind of hope I do. First off, I want to know if you can shadow a constant. Second off, I want to know, can you shadow, well, anything? Right. What? Unused variable, that's fine. Let's just print. Let's just print x twice. Wait, I'm fair. Yeah, you can just overshadow mutabilities, but can you overshadow constants? Yeah, stop with this. Who cares? Oh, fine, yeah. Apologies for the incompetence. Yep, I need to provide a type. Yes, similar. Similar, yes. Is this not going to work? Ah, here's another difference between const and let. You can't shadow a const, it seems, which is good. That's very good. It seems that you simply cannot shadow a const. You should not be able to shadow a const. That is good to know. Mutes can actually, immutable things can technically be, well, not really. Apologies, I'm not going to give some disinformations there. But you can change the value technically of a variable. Well, not technically. You can change the value of a variable if it's immutable by simply shadowing it, which will give a new value to what previously existed, but the old thing will still live in memory until both ends go. Right. This is just explaining what is happening here. I think we've already done this. Shadowing is different from marking a variable. Yep. The other difference between mute and shadowing is that because we're effectively creating a new variable when we use the let keyword again, we can change the type of value and reuse the same name. Yep. For example, say our program asks the user to show how many spaces they want between some text by inputting the space character, and then we want to store that input as a number. Oh, okay. You put in the spaces, you get the length of the string, changes it to an integer, probably 32, or maybe an I32. I32? A 32-bit integer. The first basis variable is a type string. Secondarily is a number type. Shouting thus spares us from having to come up with different names such as spaces underscore string and spaces underscore num. Instead, we can just use spaces. However, if we try to use mute for this, as shown here, we'll get a compile time error. Yep, because it's a different variable. Yep, we can understand that. Determine whether the program will pass the compiler, passes, write the output. Okay, we got let mute x 32 equals 1. We have a new scope, let mute x equals x, x plus equals 2. Print out x. It should. I mean, it is mutable, but you should be able to shadow a mutable variable, correct? I don't see any problem with shadowing a mutable variable. Yeah, does compile. X, that would equal 3. Determine if it compiles, give the output. Nope, that won't. That will not compile due to the fact that you're trying to put a string into a U32. Correct? Incorrect. Program will not be 3. Why will it not be 3? Why will it not be 3? You have x, which is, right, x equals 1, x equals 1, x plus equals 3. It should output 3. Okay. Yep, you're entirely correct. Once more, I will state, I am an idiot. Thank you for helping. That is correct. It will output 1 because it's exited the scope. Thank you. Luckily, we have debuggers where I would have found my idiocy very quickly. Thank you for that. I was testing you, Gonza. That's what was happening. I was trying to make sure you understood and not falling on my face. Thank you for that. Yeah. I'm glad that it does that to try and hit me over the head with the fact that I have to look at scope. Oh, hello. What did I do? Oh. Data types. Every value has a certain data type, which tells Rust what kind of data is being specified, so it knows how to work with that data. We'll look at 2 types of data, scalar and complex. Keep in mind that Rust is statically typed language, which means that you must know the types of all variables at compile time. Compiler can usually infer what type we want based on the value in case the types, many types are possible. When we convert a string to a numeric type using parse, the section we must add a type annotation. Right, yep. So it'll help us as much as it can, but if it can get a lot of different stuff, tell it what we need. Don't add U32, the annotation shown in the preceding code. Rust will display the following error. It means that we fucked up. And the errors are really well done. I like it. Quite well written. Unlike Python, I hate Python errors. Python errors are just trash. A scalar type. This is good to learn. A scalar type represents a singular value. Rust has 4 primary scalar types: integers, floating point numbers, booleans, and characters. You may recognize these from other programming languages. Let's jump into how they work in Rust. Integer. Alright, I don't care about reading this. If anybody doesn't understand how these work, there are some great videos out there, which I believe other people can show you. This, let's just skim it. Yep, is it going to explain what any of this means? Yep, I guess the most important thing is signed or unsigned. Signed means it can go negative, but has half the actual sizing, I guess. You can go to 128, I believe, versus negative 128 to 128, or 0 to 256 with an I8 versus a U8. U8 means unsigned 8, means it has no positive or negative signage. It can't go negative. It can only go positive. I just stands for integer, or assigned integer. Yep. It has the math here. Oh, 127. Sorry, because 0. Apologies on that. 255, not 256. Sorry about that. That was a bit of misinformation on my end. Additionally, isize and usize types depend on the architecture of your computer your program is running, which is denoted in the table as arch. Okay. If you're on a 64-bit architecture and 32 bits, right, yep. That is, what are you talking about? Yeah, that's just telling you the architecture. That is a variable which, okay, yeah. I understand. Right, integer overflow, if you go over the certain value, it'll go back to the front. Let's say you have a variable type U8. Let's see if that's actually how it works. It could just break. I've seen some that break. Yep, I think that might be it. Let's say you have a variable of U8, it can hold values between 0 and 255, and you try and change the variable outside that range, say 256. Integer overflow, which will occur, which can result in one of the two behaviors. When you're compiling in debug mode, Rust includes checks for integer overflow, which cause your program to panic at runtime. If this behavior occurs, we'll get a panic. Rust uses the term panicking when a program exits with an error. We'll discuss panics in Chapter 9. When you're compiling in release mode with the -- release flag, Rust does not include checks for integer overflow that cause panic. Instead, overflows occur. Rust performs two complement wrapping. Apologies. In short, values greater than the maximum value type can hold wrap around to the minimum of the value that type can hold. In the case of U8, value is 256 becomes 0, value is 257 becomes 1, so on and so forth. The program won't panic, but the variable will have a value that probably isn't what you're expecting. Calling on integer overflow wrapping behavior is considered an error. Well, it's good that it doesn't error out, I guess, because if it does, your entire program crashes. You can see undefined behavior over crashing. I do wish some of these languages would just allow you to break. Wrapping in almos with the wrapping _scar method, such as wrapping _add. Oh, sorry, to explicitly handle the possibility of an overflow, you can use these families of methods provided by the standard library for primitive numeric types. Wrap in all modes with the wrapping _scar methods, such as wrapping add. Return the none value if there is an overflow with the checked _star methods. Return the value and a boolean indicating whether there was an overflow with the overflowing _star methods. That's really good. I'm glad that they have methods to show you that yes, there was an overflow and it'll allow you to correct as needed. Great. Saturating the values minimum or maximum values with the saturating _star methods. What in the world does saturating mean? I don't know what that is. Apologies. What does saturating mean? I guess it just sticks at 5? What does that mean? I'm sorry, what does that mean? If anyone knows, I'd love to hear, but I really don't know. I must ask, as this is confusing and have been annoying to be entirely honest. Why do the wrapper methods, types, wrapping, and saturated both only implement arithmetic traits with their own types? I don't understand the issue with let A, wrapping 1, let B. Yeah, this is not going to explain what saturation is. Yeah, it's just talking about the specific issue. Apologies. What is wrapping add? I want saturating. What does it really do, and is it useful? Thank you. I found out about family of saturating functions and tried some explanation on the tinter. I have no idea what any of that means, but couldn't really grasp what it is. Rust documentation, to the best of my knowledge, is really robotic. Could anyone explain? Integers have a finite range depending on the number of bits n they use. So when your add, subtract, multiply two values result does not fit, something else can happen. The options are here we are, saturated at 2n minus 1 for addition and 0 for subtraction. Okay. Okay, so yeah, that just sticks at the max value. Okay, yeah, that's all it does. It saturates or desaturates, I guess, in that situation. But yeah, saturation is just, if it's 255, the maximum value, you try and add 72 to it, it'll be 255, period. That's good. I like that that's an option. Right, floating point. Rust also have two types, only two for floating point numbers, which are numbers with decimal points. That's not really what they are, but I mean, okay, sure. Rust floating types are F32 and 64, which are 32 bits and 64 bits in size respectively. The default type is F64 because on modern CPUs it's roughly the same speed as F32, but is capable of more precision. All floating point types are assigned. Yeah, they kind of have to be. Here's an example that shows floating point numbers in action. Yep, 2.0, F64. You have to define it for an F32. Floating point numbers are represented according to IEEE's 754 standard. The F32 type is a single point precision float. F64 has double precision. Okay. I can never remember what precision means. What does that mean again? Single precision floating point. Yeah, I've stopped here. Numeric operations. Rust supports the basic mathematical operations you'd expect. Yep. Adding, subtracting, multiplication, division, truncated. Okay, so yeah, if you try and divide floating point numbers, you'll get a floating point number. Try and divide non-floating points, you get non-floating point numbers, I guess, and there's modulo cell. Alright, don't think we have to go over that. Boolean type, false and true. Booleans are only 1 byte. Is the specified bool. Main conditional, yep. Character type is char, it's an 8-bit number. Really, it's an 8-bit number. Rust char type is the most primitive alphabetic type. Here are some examples of declaring a char value. Yep. Fantastic, we have a char. What's the annotation? Okay, never mind. It's not an 8-bit value because you can put... Why? Okay, thank you. This is some very good documentation. I'm glad that they've done this. Wow, I think they've really shown the audience that they're targeting with Rust here. I'm glad... Oh, it has fangs. There are little cat fangs here. Aren't you glad you're learning this language, guys? This is fantastic. I'm very glad that this heart emoji cat with fangs is available to us in the char type. Thank you for showing us this. Oh, and that's not a normal Z. I would not have noticed that if it wasn't for this cat. See, that's what... They know we have to zoom in on this. This is... Okay, so it's UTF... It's a UTF character, I guess? Just any UTF character? Thank you, Keith! Exactly. Finally, a language for us. I'm sorry, I'm going to go off into a little bit here right now. There's a Lemmy post that I found that I'm very happy to see. Maybe you've seen it too. I'm just going to bring it up. I think that is the Z using math for the integer set. Oh, well, that's great to hear. I hate how Lemmy does this. And I'm sorry that I'm showing this. This is a very professional stream for professional use cases, and I'm glad that it's not actually showing it to you. Apologies, this is wasting an absurd amount of time. Ah, there we go. Russ is like, yeah, I think you can read it. I'm gonna cut this out if I can. Apologies. I'm sorry. I saw this, and I had to show you. I can understand if I've lost all my viewers now. Goodbye, everybody. Thank you, Gonzo. Oh, we lost 2 viewers. Well, goodbye. You're not welcome in the Rust community. Note that we specify char literals as single quotes as opposed to string literals, which use double quotes. That is horrific. No, you guys saw what happened with the scoping. I'm not going to notice this. Okay. Yeah, thank you, Sorbet. Oh no, I think you just saw the entire I'm sorry, Sorbet. Okay. It's a Unicode value. Oh, thank God. I've been waiting for mine in the mail. I've been using Linux for years. I've been using Arch Linux. I still haven't gotten it. Honestly, I felt scammed. Thank you, Keith. You're my favorite guy here. Seriously. Right. It's a Unicode. Okay, so it's not. Yeah, yeah, it's UTF-8. It's UTF-8 Unicode. Once more, I am an idiot. Unicode. Unicode standard. It's Unicode UTF-8. What does UTF stand for? Yeah, Unicode is. Oh, okay. Yeah, so it is Unicode. Unicode and UTF are the same thing. I keep saying UTF-8 because that's what you should be using, but it is a Unicode scalar value. So it's UTF-8. I just. Oh, unless you're on Windows. Sorry, unless you're on Windows. At which point is UTF-16? Because Windows. Yeah, that's probably going to be different depending on the operating system you're on. If you're on Linux, it's the correct UTF-8. If it's on Windows, it's UTF-16, meaning you have to write everything. Yeah, meaning you have to write everything entirely different operating system you're utilizing due to Windows just using an entirely different char set. Fuck UTF-8, 16. I hate Windows for that. That is one thing I really hate Windows. But yep, it can do Chinese, Japanese, Korean, emojis, zero with spaces. Windows is where you want to save to the desktop, but it picks to save to OneDrive desktop. Yeah, yeah, yeah. Did you hear they're bringing sudo to Windows? I'm very happy with that. You need to put your kids to sleep? That's fine. Deep from Smoke. Thank you. It'll be available on YouTube, and I really do appreciate you being here, Gonza. You're great. Thank you. Right, so let's continue. Character isn't really a concept in Unicode, so your human intuition for what a character is may not match up with what a char is in Rust. We'll discuss this topic in detail in storing UTF-8 encoded text with strings in Chapter 8. Okay, that's a bit weird. Yep. So maybe 8, it may be 16, it may be 32 bits, so this is just a... Oh. It's a little smile! That's very good. I love that. Thank you, Q. The largest number representation of the I-128 is... Yep. That's 2 to the power of 128 minus 1. Yep, because 0 is a number. Fantastic. If x u8 is 0, what will happen when computing x minus 1? It depends on the compiler mode. Yep. Determine whether the program will pass the compiler. If it passes, yep. Right, so we have x is f size. I forget what f size is. I'm an idiot. F size. What is this? It doesn't know. Fantastic. I'm just going to pretend I know. Is 2.0. Print line. It should compile. Why wouldn't it compile? I don't understand this question. I don't remember what an f size is. It should just print out 2.0. Correct? Ah. Ah. I'm incorrect on a lot here. Wow. What is an f size? It's not described. I'm assuming that's nothing, actually. I'm assuming that's why that's there. But what is an f size? Is that a float size? Okay. Incorrect. Oh my lord, I'm an idiot. Yep. That is wrong because this is... I can understand what I did wrong here. This will actually be half that. It is correct with that. It's n to the power of b, which will be 128 minus 1, and then minus 1 again. Will it be? Perhaps not. This will not compile. Okay, yep. Makes sense. I'm just a bit of a fool here. Compound types. Compound types can group multiple values into one type, as two primitive compound types, tuples, and arrays. Tuple is a general way of grouping together a number of values with a variety of types into one compound type. Tuples have a fixed length. Once declared, they cannot grow or shrink in size. Same with arrays, correct? I'm not going to create fake arrays. So create it by using comma-separated variables, and we have to set these, dude. Unless I'm assuming it's the same thing. You found this. Done. It's a crate, a pointer-sized floating point. Okay. The size of this primitive is how many bytes it takes to reference any location in memory. What does this have to do with floating points? For example, on a 32-bit target, this is 4 bytes, and on a 64, it's 8 bytes. Okay. So first, this is a crate, which is just some plugin, some random thing that somebody made. Perhaps this is a crate created by Rust itself. It does look like that, I believe. Not fully certain what this website's supposed to be doing. But, right, so what this will do is it'll give you a bit of space which can hold a pointer. A pointer is just a label to something in memory where it's stored on your RAM. This will just give you enough space to store exactly that and nothing more. On 32-bit system, that's 4 bytes, and on a 64-bit, that's 8 bytes. Pretty simple stuff, but this is not regular. This is something that you'd have to download separately, which is fine. Now we're learning about tuples. Tuples, we create a comma-separated list of values and parentheses. Each position in the tuple has a type. Types of the different values in the tuple don't have to be the same. We've added optional type annotation in this example. Right, so you don't need this, but you can do it, I guess. You can force it, I guess, if you want an IE. Oh, no, not oops sorbet. That's perfectly fine. I do appreciate that. That's great to bring up. Alright, so variable tup binds the entire tuple because the tuple is considered a single compound element. Yep, so top will be the entire thing. But x, y, z equal top. Oh, we can use a tuple to assign variables like such. Pretty good. This program creates a tuple and binds it to the variable tup, then uses a pattern with let to take tup and turn it into 3 separate variables. This is called destructuring because it breaks a single tuple into 3 parts. Finally, the program prints the value of y, which is 6.4. We can also access the tuple element directly by using the period followed by the index of the value you want to access. Oh, I hate that. That is disgusting. No, don't. Okay, if I saw that in code, I'm glad I read this, because if I saw that in code, I'd have no idea what it meant. Why? Why? Can we just use a tuple? Like, can we just be normal? Can we just... Why? I hate that so much. Hello? No, 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 no. Why? Okay, so what is a tuple under all of this trash? Why? That is disgusting. Why are we using it like some member variable? Or like this is some form of object or some form of... I hate that so much. I mean, I know it's just syntax, Stop that, though. Just don't do that. Be better. This program creates the tuple x, then accesses each element of the tuple using the respective indices. As with most programming languages, the first index of a tuple is 0. Makes a lot of sense. It's probably just an array in the background. Well, I mean, probably very similar to an array in the background. I wonder if they have some sort of padding, or what exactly is going on with that. How is it storing the types? Apologies, I guess. Huh, I wonder. The tuple without any value has a special name. Sorry, the tuple without any values has a special name, unit. This value and its corresponding type are both written empty brackets and represent an empty value or an empty return type. Expressions implicitly return the unit value if they don't return any other value. Okay. Okay. I don't understand what that is. Yeah, it can look like an object. It does. Sorry, yes, that's exactly what my point was. Yeah, it looks like it's some kind of functional. This dot do that. I hate that so much. Dot zero? At least nobody's going to see dot zero or dot one with syntax highlighting and think that there's some variable named x dot. Well, I guess that's kind of what it is. I'm sorry, I hate that so much that disgusts me. That just, I'm going to vomit, honestly. The array type. Right, apologies. Talking about vomit, I'm going to take a moment. I will be back very soon. Sorry, I just have to take a moment. Hey, back. Apologies for that. All right. Right, so an array is another collection. We have this, which is just A. Here's an array. Fantastic. Arrays are useful when you want data allocated in the stack rather than the heap. We'll discuss this in chapter 4. Glad it's so soon. An array isn't flexible as a vector type, though. A vector as flexible. Wait. Yeah, it's a fixed number of elements, correct? It's not gonna... So, okay, it is an actual thing. A vector is a similar collection type provided by the standard library that is allowed to grow and shrink in size. If you're unsure whether to use an array or vectors, chances are you should use vector. Chapter 8 discusses vectors in more detail. Of course, that's going to be more difficult to learn than in Chapter 4, where we discuss heap versus stack. Wow. Fantastic. A vector must be destroyed and recreated on each point where you have to allocate a certain amount of memory. Vectors are cool. However, arrays are more useful when you know the amount of elements like months. Fantastic. Again, we're just going to try and run through this. We have, all right, you're running an arrays type using square brackets with the type of each element, a semicolon, and then the number of elements of the array. Yep. So this can be assumed by the compiler. You can define it if it's different than normal behavior. Okay, great. It's just going to assume it. It will, yep. Accessing elements, it's starting with 0. You can access it normally. Fantastic. Invalid array element access. Right, yeah, I guess this is something we'll have to read. Let's see what happens when you try and access it when you shouldn't. Say you run this code, send it to the guessing game. You get an array of value from the users. Fantastic. Please enter the index. You just ask for the index, get the input, let the index be a usize variable, and then get the index out. If they put it outside the index, yeah, I think we understand what's going on. This code compiles successfully, but if you run cargo run and enter 0, 1, 2, 3, or 4, the program will print the corresponding value. Instead, enter 10, it will show this. It'll panic. It'll crash. Thread, main, panicked, add index out of bounds, length of 5, the index is 10. Yep, we'll get an index. We'll get an index out of range error. Index out of bounds error. Program results in a runtime error at the point of using an invalid value for the indexing operation. The program exits with an error and didn't execute the final print line statement. In the attempt to access an element using indexing, Rust will check that the index you specified is less than the array length. If the index is greater than or equal to the length, Rust will panic. This check has to happen at runtime, especially in this case, because a compiler can't possibly know what value a user will enter when they run the code later. Now, this might seem quite obvious because a lot of other languages will give you an index out of bound error, specifically Java, Go, a lot of other things, but C won't. It'll just give you whatever's at that point. I guess to explain why, an array isn't real. It's not like some weird object, or it's not this esoteric thing. If you understand what a pointer is just a label in a row of boxes, 1, 2, 3, 4, 5, that states exactly where your data is stored. An array is a pointer to the first value in an array of a list of objects, and you take the next, let's say, 5 things, 5 boxes, 5 elements, 5 numbers, whatever they are, in a row, and you set that as a set of values which will be used for this array. It'll be cleared, nothing else can use it, that's your stuff. However, if you go 0, 1, 2, 3, 4, and then you go off to the 6th element of the array, that's no longer part of your array, that's part of God knows what. But 132, you get random memory from whatever is using it. This is a very, very bad thing, because in this specific thing, just printing it out, somebody could just ask for the entirety of your memory, just dump your entire memory, piece by piece by piece, which is a very bad security flaw. This can give passwords, this can give data from other users being brought in, this can give a lot of other stuff, as all of this is stored in memory. Like, if somebody else is guessing, using this guessing game, they could get their guesses, because that has to be stored somewhere in memory. This is very bad, but Rust is a memory-safe language. It is well, yeah, that's the entire point of it. This stops that error from being possible, as it checks at runtime whether or not this is within index. Apologies for the terrible explanation, but I think you can understand this is a good thing. This breaking is a good thing, and in things like C, this will not break. This will simply output garbage. Or the right person, exactly what they're looking for. And that's not a good thing for you. Right, question 1. Determine whether the program will pass the compiler. If it passes, write the expected output. Let message equals a string. Let x equals message 100. What? Right, so we're creating an array. Print x0, x1. We haven't initialized anything. I may have skipped over that. Apologies if I have. I definitely did. It shouldn't compile? Yeah, it should. Why not? It'll give null and null, right? I don't know, man. I really don't know what I guess so. It would compile and it would give out T and H. Sure. Make clear. Determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. Let T equals a tuple. It's an array. I really don't know what's going on here. I guess I skipped over too much. Does anyone else understand what's going on here? Apologies. You're creating a tuple, which seems to be, I really don't know what that does. Right, yeah. So T is a tuple. This looks like the beginning of an array. I don't know what that does, though. 1, 2, maybe that's another tuple? Tuple of tuples? A, B? A is... It will compile because you're using the same thing here. No, okay, so this is an array with 2 values. Okay, so this is just an unnamed array of 2 values. It's fantastic. We're just getting A, 0. It does compile. A is the first one. It gets 0. That's 1. Plus T, 1, which will be this variable. Sorry, this value. Great. So that's that should be 4. Standard output should be 4. Yep, that's correct. But what is going on here? I'm sorry, I'm just going to see the correct answer here. This does not compile. I guess it doesn't compile. Why would it? Makes no sense. Okay. Functions. Functions are prevalent in Rust code, if you've already seen one. You've already seen one of the most important functions in the language, the main function, which is the entry point, but you've also seen the function keyword, which allows you to declare new functions. Rust code uses snake case as a conventional style for variable names in which letters are lowercase. And yep. For function variable names, it uses snake case. I don't like that. I like camel case, but hey, it uses snake case. That's alright though. We define a function in Rust by entering function, followed by a function name and a set of parentheses, the curly brackets to the compiler where the function body begins and ends. You can call any function we've defined by entering its name followed by a set of parentheses. Because a function is defined in the program, it can be called from inside the main function. Note that we defined another function after the main function in the source code. We could have defined it before as well. Rust doesn't care where you define your functions, only that they're defined somewhere in scope that can be seen by the color. This would be global scope. Just to be clear, anything at the base of this file is global scope within this file. Alright, well, that's file scope, not global, I guess, but you know. Let's start anything within main.rs will in fact be global scope, because everything has to be built within this point. But if we get a secondary file, that would likely be file scope. I could be wrong on that, but I do believe that'll just be file scope, which will be brought into anything that this file brings in, but not following out. So if we get another thing called second.rs, it shouldn't take any constants from that and be usable in main.rs. It's not global scope, I don't believe. Let's start a new binary project. Great. Oh, okay. Let's create a new function. Or not to. I don't really care. Right. Functions. Oh, that's very useful. Has everyone left? We got 3 people here. I think that's including myself, so I believe quite a few people have left us, which is okay. Thank you for the 2 people who are still here, though. That's very kind of you. Alright, we've created a new thing. Hey! Thank you. Right, we're creating this. Cargo run. Alright, we're just creating 2 functions. Another function. Yep. I think by now everybody understands what a function is. If you don't understand what a function is, Rust really isn't the language for you to start learning. You should learn JavaScript or Python. We can call any function we've defined by entering its name. We understand that. The line execute. Yep. Parameters. Parameters being brought in here. I think we understand what a parameter is. Hey, Silver Sorbet. Glad to see you're still here. Try running this program. You can following output. Yep. Right, so we can understand that a function can take in parameters, which is a variable just brought in here. When you call it, you put in a number, or anything really, and it'll go through. We can understand that pretty simply. Let's go to the quiz. Keyword for declaring a new function is fn. Fantastic. Does this compile? Yep, should compile. What's the output? The output should be 0. Fantastic. I'm quickly going through this, so let's see if I fucked up. Nope, it does not compile. Why doesn't it compile? F, X, line X, determine the program. Why doesn't this compile? I was very quick with it, but oh yeah, we did not put a value. We did not put a type to this. It does not compile because there's no type. That's something that's always going to fuck me up because I am a JavaScript kitty. Fantastic. To confirm, these need types. Statements and expressions. Function bodies are made up of a series of statements optional. The ending in an expression. So far, the functions we've covered haven't included an ending expression, but you have seen an expression as part of a statement. Because Rust is an expression-based language, this is an important distinction to understand. The language doesn't have a simple distinction, so let's look at what statement and expressions are and how their differences affect the bodies of function. Statements are instructions that perform some action and generate return values. Expressions evaluate and return a value. Okay, it's pretty simple. Statements do something but don't return something, and expressions do. Let y equals 6 is a statement, but 6 plus 7 would be an expression. Function definitions are also a statement. Yep, they are a statement. In the Rust program, you've got an error. Yep, because this doesn't return any. Yep. Expected expression. An expression found a statement. That is going to continue with a bunch of errors. Why so many? Let expressions in this position are unstable. I'm curious. That is a GitHub issue. I'm not going to read this right now, but I'm going to read this after the stream. I don't know. That's cool that they just straight out give GitHub issues in the in the compiler warning. That's very strange. Note, warn unused parens on by default. Help remove these parens. That's useless because it'll break anyway. Let x equals 6 statement. We can understand that. Can't put statement where an expression is necessary. We need a value to be returned. Right. Expressions evaluate a value, so a literal will return said literal, and this will return. Yeah. I'd be a bit weird about the Stack Overflow links, because that can be changed by random moderators. It's not actually controlled by the Rust Foundation, or I guess the programmers of Rust. That would be the name. It's not controlled by Rust at all, so somebody could understand that's there and use it to promote a scam or do something terrible with it. But I'm glad that GitHub issues are there. Yes. So we have let y equals. Okay. This will work? Okay, calling a macro is an expression. New scope block created with curly brackets is an expression. What is this? Let's look at this. I've never heard of this job. Stack Overflow importer. You ever feel like all you're doing is copy pasting from Stack Overflow? Yeah. Blackjack and free and open source software with ActivityPub too. Oh god. Imagine if you could connect your Lemmy account to your Stack Overflow account and just comment from there. That would be terrible. Kind of cool though, honestly. I love the Fediverse for this. Right, so that is very funny. Thank you, Keith. This is a library to import Stack Overflow written in Python. That is quite fun. Oh, that's great. Whatever license you want it to be, as long as this license is compatible with the fact I blatantly copied multiple lines of code from the Python standard library. I love this. Oh, that's fantastic. Okay, so, yep. Here is a unnamed return. I can't remember what this is called. Yeah, I hate this. We talked about this last time. Keith, just this unnamed return. I can't remember what they called it, of course. But yeah, that's the thing. Apparently, you can just create a new scope and have that return. So you can put a function here, or well, you can put a function call there, of course, but you can have a sort of unnamed function here, I guess. Yeah, implicit return. Thank you, Keith. Thank you. But yeah, here's an implicit return being used in a scope that's just created offhand. Calling a macro as an expression. Yep. And a scope block created with curly braces is also an expression. Okay. The expression is a block that, in this case, the value is to 4, the value gets bound to y as part of the list. So note that x plus 1 line does not include a semicolon at the end. What? Which is unlike most of the lines you've seen so far. Expressions do not include ending semicolon. Okay. Okay. I don't like that. Can it? Can it? I mean, yeah, this is the end of the expression. This is okay. I'm sorry, this is going to fuck me up a lot. This is going to mess me up one hell of a lot. Whatever, I guess that's just a thing. If you add a semicolon to the end of an expression, you turn it into a statement which causes failure and crash. And it will then not return a value. Keep this in mind as you explore function return values and expressions next. So a bit of an engineering cue, but when would you do that? As someone who mostly used Python as a semi-MATLAB lab to make plots, when would you do exactly what? Oh, is the implicit return or just the semicolon, the non-semicolon? I'm sorry, I don't fully understand what you're asking. When would you use an implicit return? Or when would you use... Oh, when would you want a new scope? When would you want a new scope? Like I have let y equals and then some function within a scope? Yeah, does not help. Apologies. There's like a 20 to 30-second delay. Sorry about that, Keith. Oh, why is that pseudo function a good practice? Well, previously you would have something like apologies for this. You would have something like, well, actually, you would have to have, this would be a very weird thing now that we look at it. We would have to have this, which would, do we not have a return type? Right, so previously we'd have to have this, which is a full-on function created at global scope, which we then later call with thisr, which is not very useful for something that we're only doing once. Let's say that we have some actual work that we need to be... I don't think I would naturally think of it. That's perfectly fine, but as a JavaScript user, this is quite often something that's needed to be done. So normally we would create this function outside on global scope, but if it's only used once, that's kind of meaningless to do. We only do something once and only need to do a little bit of math on it at a specific point. It's not only a stylistic choice, this can be quite useful. I mean, it is sort of a stylistic choice, but this is very unreadable. If we have a bunch of work that needs to be done only once and only to this variable, it makes a hell of a lot of sense to just put it right here. Put it right here instead of putting it up here or out of the way in some random function that's created, or even to be putting it in some function within a function. Is that allowed? No, of course it's not. So it would have to be put just randomly off in the distance instead of exactly where it needs to be. Like, let's say you have A variable which you want to turn from a string into a number, and then, a variable which you want to turn from a number into some string, and then do some string work on it, like let's say it is a zip code, and you want to add a space in between it. It's quite a useful thing. Apologies, my explanation skills are pretty terrible, but I'd argue it's not really a stylistic choice, it is a readability choice, and it's kind of necessary. One of the advantages is that in a certain situation, it makes certain code shorter. For example, the code below, there would be at least 5 different places that would need explicit return. Are you talking about specifically explicit returns? Yeah, this is a bit of a different thing, I guess. But yeah, this is just for explicit returns. Yes, explicit returns are a bit of a stylistic choice. I would really disagree with stylistic and readability meaning the same thing. Readability is an absolute thing, I would argue. Again, right here, if there's certain work that just needs to be done on Y in this specific position at this specific time and nowhere else, putting this off in the distance is not as readable as it just being in the place that it is used for the only time that it is used. That I think is objective. I would very much disagree with stylistic and readability meaning the same thing, but I can understand why you believe that or think that at one point in time. But yeah, this answer is just about implicit return, which is a reasonable thing, though I don't really love it. Right. I don't believe I explained that perfectly, and I do apologize to you for that. Sorry about that, Keith, but I guess you're going to have to do a little bit of research yourself if that didn't fully explain it. Unless you have any specific questions that I can help answer. Oh, we got more peeps? Oh, hey, welcome! I'm very happy to see exactly one person rejoined or is a new guy. Welcome in. Feel free to comment or chat if you want. Sorry you came in quite late. We're only going to be going on for another half an hour or so, but still, very glad to have you. Thank you, Keith. Right, in this block, it evaluates to 4. We can understand that, unlike most of the line. Yep, we've read this. Functions with return values. Functions can return values to the code that calls them. We don't name the returned values, but we must declare their type after an arrow. Yep. Okay, so in order to return, you do have to state the return type. It can also likely be a tuple to return multiple variables if so on. It is implicit return. It'll return 5. Fantastic. I think we can understand that. Right. 5 in 5 is the function's return value, which is why the return is I32. Let's examine this in more detail. There are 2 important bits. The first line, let x equals 5, shows that we're using the return value of a function to initialize the variable. As the function 5 returns a 5, that is the same line as, well, x equals 5. Second, the 5 function has no parameters and defines the type of the return. Yep, we can understand that. Another example, let's x equals plus 1. 5 returns an I32, x plus 1. Of course, if x was end of a 32-bit number, it would roll over, or depending on the compiler mode. Running this code will print the value x is 6, but if we place a semicolon at the end of the line containing x plus 1, changing it from an expression to a statement, we'll get an error. Okay, yep. Because nothing is returned. It's asking to... Okay, I can understand why the semicolon now. That makes sense. Because my main issue with implicit returns is A, you can never tell, and B, you can accidentally return something. But as long as you remember to put a semicolon in, which, I mean, Keith, you can still... you can remember, I am terrible at putting semicolons in. I am a JavaScript boy. But if you do remember to put them in, you'll never accidentally return something you don't want to. That's great to see. Okay, here's the quiz. In Rust, a curly brace block like yep is an expression, a statement, a syntactic scope. It's 1 and 3. It is both an expression, which can return a value, and a syntactic scope. it's a scope. We can understand that. Determine whether the program will pass the compiler. If it passes, yep, we have a function called f, which takes an x of an i32 type and returns i32. That's just adding 1. Print line. F, we have a scope. Okay, I really hate this syntax. 1. Just 1? Why would it just be 1? It's both that and a scope. Sorry, Keith. I missed that for the first answer. Right, secondarily, we have let y equals 1. Fantastic. Y plus 1 would equal 2. So that's 2, which is returned because there is no semicolon. Returns to f, which is passed in as an i32, which is the default value variable type, which goes to x plus 1. Yep, that's 2. The 3. Turn from f into print line. Okay, so it does compile. Will give us 3. Oh, that's okay, Keith. I mean, you've seen how horrifically incorrect I've been. I believe that does compile, and it will output 3. Unless anyone wants to correct me, I guess I'll be corrected very quickly. Nope, that's correct. Fantastic. But you can tell what I'm talking about with readability. This just squirrely bracket right here, just all these. This can be a bit unreadable in some points. I can understand that. With a one-liner like this, I can understand not having a return. Right, comments. All programmers try to make their code. Yep, it's a comment. We have. Right, yep, we have comments. Comments. Does anyone not understand comments? You should understand what comments are. If you don't, it doesn't matter. Control flow. Fantastic. The ability to run some code depending on whether a condition is true, and to run some code repeatedly while a condition is true are basic building blocks of programming. If expressions, and I think this is fairly self-explanatory. If this is true, do this. Else, do this. If anyone has any basic programming experience, they should understand what. I'm just going to run over this. Yep, we've even already done this. This is just here for completion. Alright, let's. Okay. Let number equals 3. If number, print number was 3. Okay, so it must be a Boolean. It cannot just check whether or not something is something, which is a bit of a shame. The if condition evaluates a value of 3 this time, then Rust throws an error. It's not a bool. That's a shame. I really like if statements to check if something exists, is not nully. I really hate how they don't have falsy versus truthy variables, like an empty string being falsy versus a string with numbers, something in it being truthy. That's an absolute shame. It really is. Here indicates that, yep, we can understand that must be a Boolean. Must be true or false. It cannot be some random number. We have does not equal. We have multiple conditions with if else. We have else ifs. We have ifs and let statements using if and a let statement. Okay, yeah, so it can just be a 1. Okay, so here's what implicit return really helps with. Yeah, I guess so. So we have. I've never seen this before. Okay, so if does return a value. It is an expression. Okay. Well, I guess if isn't really an expression. It just runs an expression if condition. Okay. That's actually really cool. And the first time I've seen an implicit return be useful. Okay, so this is kind of like having a try. Gosh, what is it called? Cannot remember what it's called. A ternary operator. Condition, question mark, first, second. I'm glad that exists. That's quite cool and interesting. The number variable about, yep, I think that we can understand what is happening here. Yep, the question mark operator. Thank you. The ternary operator is its actual name. Thank you for that, Silver Survey. Yep. Let's do the quiz. After skipping the entirety of it. True, false. Executing these two pieces of code results in the same value for x. You want it? Yeah. Yeah, essentially. Yes. I love regex though. It's so good. I don't understand a word of it, but like it makes me feel good when it works. Okay. True, false. Executing these two pieces of code results in the same value for x. Type 1, let x. Yep. Yep. Should do the same thing. True. Fantastic. Determine whether the program will pass, and yep, let x equals 1 y if x. That will not compile because x is not a boolean. Yep, x is not a boolean. The condition in Rust does not have the concept of truthy or falsy value. I hate that. I like truthy and falsy. Repetition with loops. We have repetition with code loops. It's just the loop. We've actually used this already. We can understand it'll just run this infinitely. This is an infinite thing. It will not stop until you stop it yourself. Returning values from a loop. Oh, yeah. So again, since this is a... Okay, yeah, so again, implicit returns are being used here. I believe? No, break will return. Okay. A little bit of knowledge here, I guess. Break is just return, but from a loop. Break just returns the counter times 2. Fantastic. So break is just return, but it'll return from a loop instead of from the entire function. I'm pretty sure Rust had some weird thing that could check if things are empty or not, but I forgot about it. I assume, yeah, that has to exist. That would be very difficult to run if not, but I just think it works better if you just can do truthy or falsely. I think everyone can understand that quite easily. I can understand perhaps that would heavily decrease or increase the amount of time it takes to compile. I don't know. Yep. This is just stating exactly what I stated. Fantastic. Loop labels to disambiguate between multiple loops. I guess we should probably read this because most people haven't worked with labels. If you have loops within loops, break and continue apply to the innermost loop at that point, the loop that's currently in. You can optionally specify a loop label on a loop that you can then use break or continue to specify those keywords to apply to the label instead of the innermost loop. So if you have 5 loops, you want to go to the 3rd loop, you can just label loop 3, go back to that. You'll see here, here's how it works. It's just, hey. Okay, so it's a single quote, the label, a comma, and then the loop. That's the label. I'm going to break to this label. Kind of like go-tos, but we're not using go-tos. Interesting that it's break statement rather than a function. Where do you mean that? Oh, you could definitely use a function here too. Yeah, I hadn't thought. But yeah, you can return anything from here. Break can return anything. It could just break 73. It could just be break counter. But yeah, you can use just a regular statement. Oh yeah, break's not a function, it's a keyword. Break is like return. I just think of break as return, but for loops. I can understand why you think that, but break is in no way a function. It is just a keyword that will return some value. Right. Right, where were we? Yep, labels. You understand labels, guys? Survey, Keith? Pretty simple stuff, I guess. But I can understand someone not understanding this just straight out if they've never used it before. Yep. Okay, just going to continue on. Conditional loops with while. Has anyone not used a while loop? I doubt it. while you have a conditional, it says, hey, as long as this is true, number does not equal 0. It'll just keep running. Instead of a loop, which will run infinitely until you break or return, this will, or continue, I guess. Well, no, not continue, but yeah. So, well, number does not equal 0. Print the number minus 1, when 3 hits 1, it'll break out, and then there you go. Fantastic. Loop through a collection with 4. Okay, for a loop. What? There's no for loop here. You can choose to use the while loop. You can choose to use the while construct to loop over the elements of a collection, such as an array. For example, the loop listed in 3, 4 prints each element in the array A. Yep. That's just well, index is less than 5, which is the amount of items in here. Well, no. Oh, yeah. And it'll just loop through it, but you can probably use 4. Yep, 4 elements in A. Fantastic. This is just, hey, for the range, for every single thing in this array, it will print the element. For element will be the individual value for each part of the array. A is just the array. Fantastic. We're not going to read through that. Yeah, ranges. So, in case you've never seen this before, you can just have bracket, any number, to any number, dot rev. What does dot rev mean? What do we have dot rev? Yeah. Here's what the countdown would look like using a for loop and another method we've not yet talked about, rev, to reverse the range. Okay, so yeah. Yep. Good point. Thank you, Survey. Sorry about that. Again, with the delay, we can kind of be messed up on this. You are very quick, and I am quite slow. Thank you for that, though. Right, so that's pretty good. I'm very glad that that's a thing. But yeah, just to confirm, you can have a range, but there are a bunch of functions on ranges which you can use to change them out, like get every second, get every third, so on and so forth, change how it iterates, etc. Or in this case, go from 4, 3, 2, 1. Fantastic. This code is a bit nicer, isn't it? Yes, it is. I like that. True or false, this code will terminate. That is, will not loop forever. We have a main mute equals 0, label A, loop x, plus equals 1. Yeah, does feel quite useful for that. B, label, loop, x is greater than 10, continue to A, else break to B. Okay. Right, so x will eventually get to 10, and then false, and then it'll break to B. Break will return out. Oh, I don't know, I'm pointing at this. Break will return out to here, which will eventually break. It will, in fact, terminate. I believe, as long as x equals plus 1, that's 1, sorry, x is greater than 10. Yep, this will eventually end. Determine where the program will pass and what it will give if so. A is an array of 5 and 10. Immutable sum equals 0. X in A. For x in A. For every element in there, sum plus equals x. That's 5 and 10. Okay, yep, it should compile. Unless I'm incorrect. I believe it will. 15. Fantastic. Set query. Yep, it will end. Will not be 15, you fool. Sum is 0. Why is it not 15? It does compile, but it will not give 15 for x in A. So first x will equal 5. Sum plus equals 5. 0 plus 5 is 5. Then x will equal 10. What? I'm just gonna cheat. 50? 50. Why would it be 50? What? array A has an element of 5. Oh my god, I'm an idiot. Okay, I guess I didn't fully read arrays. And this is why you should always read the entire thing instead of skipping over everything as I've been doing with this entire listing. Apologies for that. I'm glad I've stuck into a few of these instead of like we were originally going over, just not really caring about this. Yep. Well, no. Well, yes, actually, yeah, you're right. There are 5 10s. So that's 0, 1, 2, 3, 4 is 10, 10, 10, 10, 10. I'm never going to remember that. That's never going to be a thing I'm going to remember. I'm going to break that a lot. Which is okay. But yeah, I guess this is a great way to learn that you're an idiot. Thank you, Sorbet. So yeah, that'll be 50. Okay, you made it. This is a sizable chapter. You've learned a lot about... yeah. It's actually 10 times 5? No, it's 5 times 10. The array A has an element 5. No, you're right. Actually, you are correct, Sorbet. Okay. You're entirely correct there, Sorbet. Thank you for... That would have went over my head completely. I would have never known that. Until I wrote a program and just everything broke. Okay, so Sorbet is correct. Let A equals 5 semicolon 10 means let A equals an array with the value of 5 10 times. Okay. Thank you again so much, Silver Sorbet. You saved me, honestly. I mean, it technically is the same thing within this specific scenario, but this is an array with 10 elements, not an array with 5. That is very meaningful. Thank you for that. I can't thank you enough for that. That is incredibly dumb on my end. I'm sorry, you one random person who's watching this and just had to see us fail horrifically. Thank you for sticking with us through that. I'm so disappointed in myself. You've made it. This is a sizable chapter. You've learned a lot about variables, scalar and compound data types, functions, comments, ifs, expressions, and loops. For practice with the concepts discussed in this chapter, try building programs to do the following. Convert temperatures between Fahrenheit and Celsius. Generate the nth Fibonacci number. Type the lyrics to A Christmas Carol, 12 Days of Christmas, and take advantage of the repetition of the song. When you're ready to move on, we'll talk about a concept in Rust that doesn't commonly exist in other programming languages: ownership. That's the big thing. That is the big thing. That is something that we have to focus on incredibly. Like, that is apparently just the thing with Rust. No. Oh, yes! I'm excited. I am excited. Alright, so honestly, we have 10 minutes left. I don't think that's really enough to do much. We might get the temperature in Fahrenheit or Celsius, so I guess this will be homework. Apologies for not getting through the next 2 chapters, but there were a few things which I didn't honestly think we'd be getting into, which we did. Anyway, thank you guys so much for being here, but I am going to be ending for tonight. We will be meeting again in 1 week on Tuesday for this once more. Thank you for being here twice in a row, Keith. Thank you for coming in, Sorbet, for the first time, I believe. But I think this is where I'm going to leave you. I will state, well, all of us should be doing these 3 exercises on our own. I'm going to be doing it probably tomorrow, or Wednesday, or Thursday. Now, I will say I will be streaming on Thursday where I'm going to start the Advent of Code doing Rust. If you want to join me there, I'd love to see you. Love to get your help, because I'm an idiot. And we've seen that throughout this. But, once more, I'm going to say goodbye, and I am going to end the stream. I will make a good effort to be able to be present, even though I won't. That's perfectly fine if you're not present. Thank you, though. Take care. Goodbye. Love yourself.